So welcome to physics online session. So in this today's class we will discuss problems from dual nature of radiation and matter. We will discuss the first problem from this chapter. So when a monochromatic light of frequency 6 into 10 power of 14 hertz is produced by a laser. So here the frequency of light emitted by a laser was given as 6 into 10 power of 14 hertz. The power emitted is 2 into 10 power of minus 3 watts. The question is, what is the energy of a photon in the light beam and how many number of photons emitted per second on an average? Okay, that is what we need to find. Solution to first example problem. This is an example problem from the textbook. Okay, so what is given? So it is given that given frequency of light, frequency generally represented by nu or f. Nu is equals to 6 into 10 power 14 hertz, okay, or second inverse. Okay, now what is the power? So given that power P, so power P equals to 2 into 10 power of 3 minus 3 watts or 2 into 10 power minus 3 joule by second. Okay, this is another unit of power. So and it is asked to find what is asked to find. So it is right, what is energy of photon? So energy of photon, according to Max Planck's quantum theory, energy of photon is quantized and energy of one photon is given is equals to h nu. Okay, so this is the first question we need to answer. What is energy of photon? Okay, this is what we need to find. So where E equals to h is a Planck's constant, where h Planck's constant, and its value is given by 6.63 into 10 power of minus 34 joule second. Okay, so therefore E equals to h nu is equals to 6.63 into 10 power minus 34, so joule second, into the frequency is 6 into 10 power of 14 second inverse. Another unit of frequency is second inverse. Okay, therefore E equals to, and answer is 6 3 is 18. Okay, 6 6 36 37 6 6 36 39. So this is the energy. So 39.78 into its second inverse cancel. So what do you get? 10 power of minus 34, here 14, so you will get 10 power of minus 20 joules. In the textbook it is given as 3.98 approximately 9.7, so you can write it as 98 into 10 power minus 19 joules. Okay, 1 minus 10 power minus 1 is multiplied, then you will get this answer, and this is the first answer. Okay, the energy of one photon, this is the energy of one photon. Okay, Right, next I am going to the second problem, number of photons emitted. The second one is okay. Second problem, number of photons emitted per second. Number of photons emitted per second. Number of photons emitted per second. Okay, so let n be the total number of photons, n by t, number of photons emitted per second. Okay, therefore, okay, we know that power P equals to power P is equals to, so energy, actually total energy of photons by time, work done by time or energy by time, that is the what that is about the power. So there is no space, I want to use this space here. Okay, I'll use this space. Okay, right, therefore P is equals to energy of photons. How many photons are there, we don't know. Let n be the number of photons, and energy of one photon is equals to E. Therefore n is represent the total energy of all photons, and this is T. So that implies n by T is equals to P by E. Okay, therefore number of photons emitted per second, so this gives a number of photons emitted per second is equals to P power is given as, what is the power? So power is 2 into 10 power of minus 3 joule by second. So 2 into 10 power of minus 3 joule second inverse divided by energy of photon equals to h nu, and that is given by nu. The frequency is energy of one photon is given by 3.98 into 10 power of minus 19 joules. Okay, here joule got cancelled, therefore number of photons emitted per second, so I'll use calculator here. So use calculator. Okay, right, so what is the value, what we need to find here, sorry, L, right, 2 divided by 3.98 is equals to this one, 0.5, approximately 0.50, 0.5. So into 10 power, what is 10 power minus 3 minus 19, we will get 10 power of minus 16. Okay, so right, we will get it as 5 into 10 power of, okay, and actually you will get positive sign, so 5 into 10 power of 15 hertz. Actually it is 5 into 10 power of 15, not hertz, there is no second inverse number of photons per second. Okay, so let it be the small n. So therefore total number of photons emitted per second is given by n is equals to, sorry, n is equals, small n represent the number of photons emitted per second, capital N represent the total number of photons. Okay, this is the answer. Okay, this is the first problem, and the second one is, okay, right, the work function of cesium. Solution of second problem, work function of cesium work function of cesium metal is given as pi naught is equals to 2.14 electron volts. Okay, and it is asked to find the threshold frequency. It is asked to find threshold frequency. Threshold frequency nu naught is equals to pi naught by h. So pi naught is equals to, it in the joules it can be written as 2.14. it is in electron volts in joules. To convert into joules, we need to multiply it with 1.6 into 10 power of minus 19 joules. Okay, so this is equals to 1 electron volt. So 2.14 electron volts equals to okay, I will multiply it here only. 1.6 into 10 power of minus 19 joules divided by the Planck's constant is given by 6.63 into 10 power minus 34 joule second. Okay, therefore the frequency is given by I'll write it as 2.14 into 1.6, so divided by 6.63 into 10 power of what do you get here 20. If you remove 20, so we'll get it as plus 50. You got 10 power 15, simply 10 power 15, 10 power 15 second inverse. Okay, so that is equals to what? Okay, so I'll write it in the next step better. Okay, I will write the answer here. Therefore threshold frequency nu naught is equals to, what is the threshold frequency? Minimum frequency so required to emit photoelectrons from the metal plate. Okay, minimum frequency required for the ejection of electrons from the metal plate. Okay, if the frequency of incident light is below this frequency, no emission of light takes place. Okay, that is called threshold frequency. Okay, now I will find out. So what is the value? Okay, sorry, I'll minimize it. Right, now so here 2.14 into 1.6 is equals to this one, and divided by 6.63, so equals to 3. We got it as 3.424. Okay, so we got 3.424. Well, answer is 3.424 into 10 power no, you got wrong answer actually 0. So once again I will see what is happening here. So 3.24 by 6.63, we got it as the answer is 0.516. okay, the answer is 0.516. sorry, so this is wrong. So the answer is 0.516 into 10 power of 15 second inverse. Okay, or threshold frequency is equals to 5.16 into 10 power of 14 second inverse, or hertz. It's a frequency, is a unit of frequency. Therefore threshold frequency equals to 5.16 into 10 power of 14 hertz. Okay, right. So this is the first part of the second problem. And what is the second question asked in this examples number 2? The wavelength of incident light if the photocurrent brought to 0 by the potential of 0.6 volts. It is asked to find out the wavelength of incident light. okay, when the potential, stopping potential is 0.6. okay. So from the Einstein's photoelectric equation we have one expression, that is h nu is equals to, from Einstein's relation photoelectric effect, we have h nu is equals to actually, so I will write so okay, the energy of incident photon utilized in two parts. One is used to free the electron from the metal plate, that is called work function, and the remaining gives the kinetic energy, that is Ke. okay, a charged particle is accelerated through a potential difference V, so then its kinetic energy can be written as pi naught plus EV naught, where V naught is a stopping potential. So where V naught is the stopping potential, V naught is the stopping potential. okay, so right, pi naught already given to us, so 2.14. kinetic energy we can calculate with the help of stopping potential, and nu is not asked, it is asked to find out the threshold wavelength of, not threshold wavelength of incident light, where nu is the frequency of incident light. So we will calculate it as, we can write it as hc by lambda, okay, is equals to pi naught plus EV naught. So where lambda is equals to, we can write it as hc into 1 divided by pi naught plus EV naught. okay, therefore lambda is equals to the value of Planck's constant 6.63 into 10 power of minus 34 into 3 into 10 power of 8 divided by, so pi naught is 2.14 electron volts and its value in joules is 1.6 into 10 power of minus 19. So when you multiply it with 1.6 into 10 power of minus 19, it will be converted into joules, and E nothing but 1.6 into 10 power of minus 19, the stopping potential is equals to 0.6. okay, so by multiplying, so after simplification of this value, so we will get it as lambda is equals to approximately, I am not calculating here, I am leaving it to you. So we will get it as 454 into 10 power of minus 9 meters, so or 454 nanometers, 454 nanometers. okay, right. okay, this is a second question, this is answer B answer. okay, this is answer A answer, sorry, this is A answer A. This is second problem. And third problem, the wavelength of light in the visible region is about 390 for violet. Solution: for violet color, the wavelength of violet V, lambda V equals to 390 nanometers, that is equals to 390 into 10 power of minus 9 meters. okay, and for yellow green color, mixed color, this is yellow green color, yellow green, so the wavelength is 550 nanometers, that is equals to 550 into 10 power of minus 9 meters. And for red color, it is about, for red color the wavelength is 760 nanometers, that is equals to 760 into 10 power of minus 9 meters. okay, so this is a given data, and So it is asked to what are the energies of photon in electron volts for violet average wavelength, that is yellow, green color, red color wavelength. First we need to find, in the first half of this problem we will find the energies of these wavelengths. Okay, energy of violet light is given by E equals to hc by lambda. Okay, therefore the Planck's constant value is 6.63 into 10 power of minus 34 joules second into the speed of light is 3 into 10 power of 8 meter per second, and whole divided by the wavelength of violet light is 390 into 10 power of minus 9 meters. Okay, so after the simplification of this value you will get it as 390, actually the numerator value is 19.89 into 10 power of minus 26, so divided by 390, nothing but 39, this is 39 into 10 power of minus 8. So after the simplification we will get it as E nu is equals to 19.89, actually I will remove this one, 19.89 divided by 39 is equals to 0.51. okay, we will get it as 0.51 into 10 power of minus 26 plus 8, what do you get, 10 power of minus 18. So we can write it as 5.1 into 10 power of minus 19 joules. When it is converted into electron volts we will get it as E nu is equals to 5.1 into 10 power of minus 19 joules divided by 1.6 into 10 power of minus 19 joules by electron volts. We will get it as joules got cancelled, so 1 electron volt is equals to 1.6 into 10 power of minus 19 joules. Okay, and 1 joule is equals to what, 1.6 into 1 divided by 1.6 into 10 power of minus 19 joules, that is why I divided with it. Okay, so we will get it as 10 power of minus 19, 10 power of minus 19 got cancelled, and 5.1 by 1.6, what is the value of 5.1 divided by 1.6 is equals to 3.18, this is 3.18 electron volts. Okay, so 3.18 electron volts. The energy of violet light is 3.18 electron volts. The space is insufficient, so I will write the energy of this violet as, I will write the energy value here, and EV equals to 3.18 electron volts. We got the energy of violet light as 3.18 into 3.18 electron volts. Okay, similarly we can find energy of yellow green as, energy of yellow green as, so I will use this relation. So the numerator is same, 19.89 into 10 power of minus 19, so numerator is same, denominator the wavelength will change. So therefore here the wavelength of yellow green is 550, nothing but 55 into 10 power of minus 8, that is equals to, what do you get, 19.89 by 55, 19.89 divided by 55 is equals to 19.89 by 55 equals to 0.361, 0.3616, get it as 0.3616, that is equals to what do you get, into 3.13616 into 10 power of minus plus 8. What do you get? Plus 18 plus 18, you will get minus 18, sorry, 10 power of minus 18. You can write it as 3.6 into 6 2 into 10 power of approximately 2 into 10 power of minus 19 joules. When it is converted into electron volts, we have to divide it with 1.6 into 10 power of minus 19, 3.62 by 1.6 into 10 power of minus 19. So electron volts is equals to, so once again we will calculate it as 3.62 by 1.6. What is the value of 3.62 by 1.6? 3.62 divided by 1.6 is equals to 2.26. This is 2.26 in electron volts, simply 2.26 electron volts. Okay, this is the energy of what we 2.26 electron volts. We got the energy of yellow green as 2.26 electron volts. Okay, 2.26 electron volts. Next you will find the energy of the last one. Okay, so I will do here the third one, energy of better to use this one only, energy of red. So the numerator is same, 19.89 into 10, 19.89. so what is the wavelength? 76 into 10 power of, so I will write it as 76. Okay, and this value is same, 10 power of minus 18. So what we got in electron volts, we can write it as, okay, I will write it as, okay, first I need to simplify it. 19.89 by 76, 19.89 by 76 is equals to 0.261, 0.2617, 0.262 into 10 power of minus 18. So we can write it as, so 2.62 into 10 power of minus 19 joules divided by, when it is converted into electron volts, we can write it as we have to divide it with 1.6 into 10 power of minus 19. Therefore ER is equals to, so now we will calculate 2.62 by 1.6. 2.62 by 1.6 equals to 1.6, what is the value? 1.637 electron volts in electron volts. In joules, this is a value of red color light. So what is the value? 1.637 is the answer, 1.637. So energy of red color is 1.637 electron volts. Okay, these are the energies. Okay, so I will remove the remaining so that it is easy to do the another problem. So I will remove this one, so better to remove this one. Okay, so the next part of this question is given by, we will see the next question here. So from which of the photosensitive material with work function listed in the table? So we don't know that one. First we will see the PowerPoint. So in that we have the work function of all metals. So it is no, these are the work functions of different materials, work function of cesium, potassium, sodium, calcium, etc. So work function of cesium is 2.14 electron volts. Okay, now what are the work functions of what are the energies of violet energy of violet is 3.18 electron volts. Okay, so work, I will write the values here. Work function of cesium is equals to what is the value? 3.24 electron volts, and work function of sodium is equals to 2.7. Work function of potassium is 30. Work function of potassium is 2.30. Work function of sodium is 2.75. Work function of other metal, that is calcium, it is 3.20. Work function of calcium is 3.20. These are measured in electron volts. Okay, right. Now these are the photosensitive materials. So energy of violet color is about 3.18. So with the violet light, if the energy of here the energy of light should be more than the work function, then only it can cause photoelectric emission. So see the energy of violet light. So energy of violet light is 3.18. So it is more than the work function of cesium, so it can cause photoelectric emission with the cesium material. When violet light incident on the cesium, photoelectric emission takes place. Okay, when a violet light incident on the potassium, also photoelectric emission takes place. Why? Because energy of violet light is more than the work function of potassium. So this was also takes place with the sodium also, but with the calcium. So when violet light incident on the calcium, so whose energy, the energy of violet light is just 3.18 electron volts, but the work function of calcium is 3.20. It is not sufficient to remove electron from the calcium material. So these three, okay, so are suitable for violet. Okay, next one, with, for example, if we are using yellow green light, with yellow green light, the energy of yellow green light is just 2.26. So just only cesium is, with only cesium, so only suitable for cesium. Okay, it can cause photoelectric emission when this yellow green light incident on a cesium material. So when yellow green light incident on potassium, sodium, calcium, no emission of electron takes place. Why? Because energy of yellow green light is less than the work functions of these three materials. Okay, no photoelectric emission takes place. Next, the last is red color. So red color, the energy is 1.637 electron volts. So no emission of electron takes place with any one of this material. So energy of red color is 1.637 electron volts, but for cesium 2.24, it is less than the work function. So no emission takes place with any one of these materials. Okay, right. Now this is about the third problem. Okay, and the next one, I will remove this one also. This is the previous problem answer. Right. Next next problem, so I will remove this one also. Okay, solution to 11.4 problem. What is the de Broglie wavelength associated with an electron moving with a speed of 5.4 into 10 power of 6 meter per second? Okay, and if a ball of mass 150 grams traveling at 330 meter per second, what is the de Broglie wavelength? So what is the de Broglie's hypothesis? A material particle in motion associated with a wave, that is called de Broglie wave, and we need to find out the wavelength of the de Broglie wave. So there are different, what is according to first we will write the given data. So given that speed of electron, so VE equals to, I will write VE, speed of electron 5.4. So it is moving with the large speed, almost 1/100th of speed of light. So and this mass of ball is given as m is equals to 150 grams. It is in CGS system. I need to convert into kilograms, so 0.15 kg, 0.15 kg. And speed of the speed of ball is given as, this is mass of ball, speed of ball Vb is equals to 30 meter per second. It is asked to find the de Broglie wavelength associated with electron as well as with a ball. So first question, de Broglie wavelength associated with electron, lambda electron is equals to, so the formula is h by p, first relation, or h by mv, where p is a momentum, product of mass and velocity. Planck's constant 6.63 into 10 power of minus 34 joules second, divided by mass of electron. Actually this is mass of electron and the speed of electron. Mass of electron it is not given, but we know the mass of electron as 9.1 into 10 power of minus 31 kilograms. So here it is 9.1 into 10 power of minus 31 kg into velocity of electron is given as 5.4 into 10 power of 6 meter per second. Okay, so after simplification, what do you get? Better to simplify it. 6.63. First I will remove the powers here. Post 10 power minus 34, 10 power of, it is 10 power of after 10 power minus 31 and plus 6, so we will get it as 10 power of 25 and minus 34 plus 25, 10 power of minus 9, 10 power of minus 9, so meters. Okay, so 6.63 by 9.1 into 5.4, 6.63 divided by 9.1, so divided by 5.4 equals to, so what is the value here? We got 0.134, approximately 0.13. Okay, it is 0.13 into 10 power minus 9, so 0.13 nanometers. 0.13 10 power of minus 9, nothing but 0.13 nanometer. This is the wavelength of electron associated with the this is a de Broglie wavelength associated with electron, which is moving at a speed of 5.4 into 10 power of 6 meter per second. Now next case we will find out the velocity de Broglie wavelength associated with the ball. So when electron is moving with a speed, okay, so any particle is moving with the speed, so wave is associated, that is called de Broglie wave. This is a particle. Okay, when a particle is in motion associated with a wave, that is called de Broglie wave. So we have calculated the wavelength nothing but distance between two crests. Okay, for ball, so we will find it as mb vb, so the Planck's constant 6.63 into 10 power of minus 34 joule second, divided by mass of the ball is given by, mass of the ball is given as it is about 0.15 kg, 0.15 kg into the velocity of the ball is 30 meter per second. So we can write it as 6.63 into 10 power of minus 34, so divided by 15 3s of 45, it is about, okay, 31.5 and 4.5, we will get it as 4.5, and lambda b is equals to, we will calculate 6.63 by 4.5, 6.63 divided by 4.5 is equals to 1.47, that is 1.47, 1.47 into 10 power of minus 34 meters. Okay, So here the wavelength of ball is negligibly small, very small. Okay, so it is beyond the experimental observation, so the wave nature is negligible here. Okay, right. This is about the fourth problem. Next, fifth one, an alpha particle and a proton have the same kinetic energy. Okay, so kinetic energy of alpha particle is equals to kinetic energy of alpha particle, and kinetic energy of proton, both are same, both are having the same kinetic energy. Which of the particle has the shortest wavelength? Okay, so de Broglie wavelength is generally it is given as lambda equals to h by, in terms of kinetic energy it is under root of 2 mke. Okay, since both the particles having the same kinetic energy, okay, lambda actually is inversely proportional to, since kinetic energy is same, so then lambda is inversely proportional to under root of m. Okay, so by using this relation we can say that larger the mass, inversely proportional, larger the mass, shorter is the de Broglie wavelength, shorter is the de Broglie wavelength associated with. Okay, therefore mass of the alpha particle is large. Okay, mass of alpha particle is greater than the mass of proton, therefore we can say that which of the following particle has the shortest wavelength. So the larger mass particle will have the shortest wavelength, so alpha particle has the shortest wavelength. Okay, that's it, no need to solve this problem. Okay, next one, I think okay, we will see what is 11.6. a particle is moving 3 times as fast as electron. Okay, so velocity of particle is equals to 3 times as fast of electrons. So velocity of particle is 3 VE. Yes or no? Velocity of particle is moving 3 times as fast as electron. Okay, as fast as electron, and the ratio of de Broglie wavelength of particle to the electron is the ratio of de Broglie wavelength of particle, de Broglie wavelength of particle to the electron is given as 1.813 into 10 power of minus 4. Okay, so now what is asked? Calculate the particle's mass and identify the particle. Okay, so mass of the particle and what is the particle, we need to find mass and identify the particle. So with the mass we can identify the particle. Okay, now I'll try to find this relation lambda p, where lambda p is equals to h by mp into vp. Okay, lambda is equals to h by me into ve. So we can write this expression as lambda p by lambda e is equals to h by mp vp divided by h by me ve, that is equals to me ve by mp vp, that is equals to lambda p by lambda e is equals to me. What we need to find? Mass of the particle. Okay, yes, so I'll remove this one, and the value of this one is given as lambda p by lambda e is equals to 1.813 into 10 power minus 4, and this value is given as 1.813 into 10 power of minus 4 is equals to me ve by mp vp That implies we need to find mass of the particle, that is equals to mass of the electron 9.1 into 10 power of minus 31. The velocity of electron you don't know, so it is given as, I will write it as VE only, mass of the particle we need to find, and this is 1.813 into 10 power of 4 or minus 4, it is minus 4 into velocity of the particle, it is given as 3 times the velocity of electron. VE got cancelled, so we got the velocity of electron approximately 1.675 into 10 power of minus 27. It is either the particle is proton or neutron. Okay, right. So this is about the, so we have identified the particle. So actually right, next the problem number 7, the last problem from this chapter. What is the de Broglie wavelength associated with electron accelerated through a potential difference of 100 volts? We have one more expression for de Broglie wavelength, that is lambda associated with electron, that is lambda E. In the concept we have discussed already, we have calculated the de Broglie wavelength of electron as 12.27 angstroms by under root of V, nothing but angstrom, nothing but 12.27 into 10 power of minus 10 meters divided by root V. V is a potential difference V is given as 100 volts. This is a potential difference, V is given as 100 volts. Okay, this is 100, so we will get it as lambda electron is equals to 12.27 into 10 power of minus 10 meters 10, that is equals to 1.227 into 10 power of minus 10 meters. So lambda electron is equals to 1.227 into 10 power minus 10, nothing but angstrom. So this is a de Broglie wavelength associated with a electron. Okay, so with this problem, so we have completed all the problems from this chapter. Okay, I think you understood the problems. Okay, thank you.